Hello everyone, so we are here with practice at 3.5 and geometry standard 10. So the first question given here is, you can see this is a tangent and this is a secant. Okay, when a tangent and a secant meet outside the circle, then we follow a particular property. Okay, so that is called tangent secant theorem. And here PQ is given 12, PR is given 8, so we have to find PS and RS. Okay, so how will we find? See, first we'll write ray PQ is tangent touching to the circle at point, which point? Q. Okay, and line PRS is secant intersecting the circle at points R and S. This is the general introduction we have to give. Then we can write PQ square, tangent segment square is equal to PR into PS. Okay, this you have done by tangent secant theorem. Okay, tangent secant theorem. Now we'll substitute the values. PQ square is 12 square, PR is 8 and PS we have to find out. Okay, now PS is equal to 12 square is, I'll write it like this, 12 into 12 upon 8. Okay, then 4 2s are 4 3s are, then 2 1s are 2 6s are. So PS is what? 6 into 3. So PS is equal to 18. Correct? PS is equal to 18. So we can find now RS. RS is equal to PS minus PR. RS is PS minus PR. What is the reason? P dash R dash S. They all three are collinear. Okay, so it is 18 minus PR is 8. So RS will be how much? RS will be 10. Okay, then question number 2 given is RD is 15, DS is 4, MD is 8 and we have to find DN. This is just the first part. The second part of the question we'll do afterwards. But here you can see there are two chords that are meeting inside the circle. Okay, there is a separate property for two intersecting chords. Okay, so first we'll write down solution chords MN and chord RS intersect each other at point D inside the circle. Okay, therefore by theorem of internal division of chords, by theorem of internal division of chords, we'll have, see like this, MD into DN, MD into DN is equal to RD into DS. Okay, very simple. Only this much formula you have to learn, then you can do any sum of these type. MD is 8, DN we have to find, RD is 15, DS is 4. So DN is equal to 15 into 4 upon 8. Okay, so 4 ones are 4 twos are. What is 15 upon 2? 15 upon 2 is 7.5. Okay, centimeter is not given, meter is not given, so keep it as it is. Okay, then now in part 2 of this sum we are given RS. Okay, RS is how much? RS is 18. Full RS is 18. Out of that MD is 9, DN is 8. So we have to find DS. Now very simple. If I tell you this is 18 and out of this 18 this is 10. This is 10. So how much will be this? DS? DS will be 8. Yes or no? How you did? 18. This is 18. This is 10. So this is 18 minus 10. So if I take this as X, so this will naturally be 18 minus X. Okay. So let us begin. We will find DS. So solution, let dr be X. Okay. Therefore, ds is equal to 18 minus x. Correct? So, we got ds as 18 minus x. Now, we can use by theorem of internal division of chords. Okay, theorem of internal division of chords. We have RD into DS is equal to MD into DN. Okay, correct? RD into DS is equal to MD into DN. Now RD we have 9, DS RD we have X and DS we have 18 minus X. Correct? And MD we have 9, DN we have 8. Okay, so this becomes 18x minus x square is equal to 72. Okay, now if I bring this here, x square, this I have to make positive, so this will become x square. This I will bring it in the RHS, so it will become minus 18x. 72 is already in the RHS, so sign will not change. Equals to 0, instead of writing here, I'll write here. Okay, so we got, you can see we got a quadratic equation. Okay, so 18 and 72. Okay, what are the factors of 72? That will give you 18. They are 12 and 6. Minus 12x minus 6x. Okay, plus 72 equals to 0. Okay, so x common, x minus 12 minus 6 common, x minus 12. X minus 12 common, x minus 6 equals to 0. X minus 12 equals to 0 or x minus 6 equals to 0. Therefore, x is equal to 12 or x is equal to 6. Okay, so we are getting dr. Okay. Therefore, dr is equal to 12 and ds is equal to 6, or dr is equal to 6 and ds is equal to 12. It can be either ways. This is 12 6 or this is 6 12. It can be both. Okay, so very simple. Coming to sum number 3, you know this is a tangent and this is a secant. So by tangent secant theorem, we'll have AB square is equal to AC into AD. Okay. AB is given 12, AC is given. So we can find AD. Three things they have asked to find. So we'll start. AB is tangent to the circle and ACD is the secant. Okay. So by tangent secant theorem, we'll say tangent segment, the second segments theorem. Okay. Tangent segment theorem will be different. So now it will be AB square is equal to AC into AD. Okay, so 12 square is equal to 8 into AD. Correct? So here also it will be AD equals to 12 into 12 upon 8. Okay, so 4 2s are 4 3s are 2 1s are 2 6s are. So we got AD is 18. Okay, now because AD is 18, AC is 8, we can find DC. Therefore, DC is equal to AD minus AC. You can see DC means AD minus AC. So it is 18 minus 8. So it is DC is equal to 10. Okay. Now because DC is equal to 10, we can now find DE. How? DC is a chord where you have OE perpendicular to the chord. So you remember the formula? OE is perpendicular to DC. The property says that perpendicular drawn from the center of the circle to the chord bisects the chord. Okay, now perpendicular drawn from the center of the circle to the chord bisects the chord. So I can write here DE is half of DC. This is the reason I have written before writing the statement. So it is half of DC is how much? DC is 10. So we got DE is equal to 5. Centimeter is not given, so I'll write it as it is. DE is 5, DC is 10 and AD is 18. Okay, very easy. Then, so coming to sum number 4, we are given what is PS, what is PQ and what is QR. Okay, and we have to find TS. This is nothing but 2 secants. Okay, as you had before in second one, you had 2 chords meeting inside the circle. These are 2 chords, or you can say 2 secants that are meeting outside the circle. Okay, so when 2 chords are meeting outside the circle, it will be like this. PS into PT is equal to PQ into PR. Okay, one more time. It will be, we'll start from this point, the meeting point of 2 secants. PS into PT is equal to PQ into PR. Okay, now see this, because you have got this PS into PT is equal to PQ into PR, we should know what is PR. So I'll first find PR. PR is nothing but PQ plus QR. Okay, they are collinear, so write this reason. PQ is 6, QR is 10, so PR is 16. Okay, so I'll write here by theorem of external division of chords. Theorem of external division of chords. We have PS into PT is equal to PQ into PR. Okay. Now we'll write PS is 8, PT we have to find. Okay. So PQ is 6 and PR is 16. So PT is equal to 6 into 16 upon 8. Okay, this is 1 za, 2 za. So PT we got 6 2 za 12. But we don't want PT, we want TS. Very simple. TS is what? PT minus PS. TS is PT minus PS. So that is equal to 12 minus 8. So how much is TS? TS is 4. Okay. Coming to next one. Coming to sum number 5. We have this triangle where DF is the tangent and DGE is the secant. They have told radius we can take R and EF is the diameter. Okay. Now because EF is the diameter, you can see this radius will be perpendicular to the tangent. Okay. What we have to prove is DE into GE. DE into GE is equal to 4 times R square. Okay. First we'll write what are we actually getting when a tangent and a secant actually meet outside the circle. Okay. So I'm straight away writing DF is tangent and DGE is secant. Okay. Therefore by tangent secant segment theorem, DF square is equal to DG into DE. Correct? DF square is equal to DG into DE. Okay. Now in triangle DFE, this I'll give it as 1. You can see triangle DFE, angle DFE equals to 90 degree. This is by tangent theorem. Okay. We have, now we can apply Pythagoras theorem. So we have DE square is equal to DF square plus EF square. Correct? This becomes hypotenuse. So DE square is equal to DF square plus EF square. Okay. Now I'll write this DF square plus EF. I'll write R plus R, 2R. Correct? 2R square. Okay. So now DE square is equal to DF square plus this becomes 4R square. Correct? This will become 4R square. So if I write this here, 4R square is equal to, so I have DE square minus DF square. Correct? So now see, again I am writing 4R square is equal to DE square minus DF square. I can write it DG into DE. This is from 1. Okay. Instead of DF square, I am writing point number 1. Okay. Can I take anything common here? Yes. DE I can take common. So what remains is DE minus DG. Okay. So 4R square is equal to DE is common, DE minus DG. Can you tell me what is DE minus DG? DE minus DG is nothing but GE. Okay. So if you see, actually we have got 4r square is equal to dE into GE. Correct? So hence proved. So with this we complete our practice at 3.5. Goodbye. Good luck.